Oh yes, I forgot that Zoom gives you that. I've got it, or no, I want to leave the meeting because I don't like it being recorded. Right, okay, let's crack on. Right, thank you very much, everybody, for attending this afternoon and taking some time out of your schedules to come and listen to us for our sort of first LDF talk that we're doing here. So we're doing a talk today on containerized microservices with a really catchy, strappy headline of "Is Docker a blocker?" I wonder if that was the thing that sort of lured everybody or not. I'm not sure. So you'll either be really disappointed or you'll be extremely pleased with whatever happens at the end of it all. Right. So let's go in there. So we've got a bit of just set an agenda, just let you know what we're going to be running through today. But to start off with, we'll just do some introductions. So my name is Tom Amos. I'm a lead technical consultant at Answer Digital. I've been with the company now for about 12 months after many years in the healthcare setting. And like I said, lead technical consultant. I do a lot of solution architecture, and that's sort of my main area of expertise in here. I'll pass you on to Alex.
Hi everybody, I'm Alex Woodhead. I'm a tech lead at Answer Digital, working for Answer for a little over a year and a half now. About 15 years experience in development, primarily in .NET land. I've been working with Kubernetes for a few years now and had lots of fun along the way. And obviously with running Docker and containerized applications as part of that.
And I'm Chris Blow. I've been with Answer for best part of 9 years. I sit halfway between the development and the consultancy space in the more DevOps area, and I've worked on a number of projects that use Kubernetes.
Brilliant. Thank you very much, gents. Okay, so these are kind of the areas we're going to look at today. We're going to go through sort of a bit of an overview of a container, what that is, two types of different architectures, monolith, containerized microservices, and then we're going into a bit of detail about some of the technology used there, and then some takeaways and some of our own experience in this area as well. Okay, so if we're sort of kicking off then, what is a container? If we're going to take a look at that, then where we would start is that containers are a form of operating system virtualization, I guess at its sort of like lowest level. We've got a single container, might be used to run anything from a small microservice or software process all the way up to a large scale application. And then inside a container, this is quite important, we've got all the necessary executables, binary code, libraries and configuration files that are required to make your microservice or piece of software actually run. In larger application deployments, multiple containers may well be deployed as one or more container clusters. And these clusters might be managed by a container orchestrator. And that is certainly something that we'll get onto later on in the slide deck. So taking a look at the container sort of view of the world then, some pros or some benefits, I guess, of using containers. They require less system resources than your traditional or hardware virtual machine environments, simply because they don't include the operating system images. And you can see that here from the slide deck there. We've got virtual machines hosting individual apps, and you can sort of imagine the overhead nightmare with that versus what we can get with a containerized application setup. Applications that run in containers, they can be deployed very easily over multiple different operating systems and hardware platforms. So it allows us to package everything up, have it in this single unit that we can then ship, put it wherever you need. It allows your DevOps teams to know that applications in containers will run the same regardless of where they're deployed, which is really interesting and highly key when you've got maybe a large application and you're trying to look after it with quite big teams, separated all over the place geographically as well. That really helps. On the efficiency side, you can rapidly deploy them, you can patch them, you can scale them, and scaling really is the king here when it comes to using containers and what it offers. What using containers can offer you in that scaling department when you're trying to look at your application performance. In general, using containers does support your agile and your DevOps efforts, basically, to sort of accelerate that development, test and production cycles out there. quite a few good things there about containers. But I guess on the slightly downside, if you could call it that, sort of the two that I'd like to sort of mention really is the whole familiarization and that paradigm shift of thinking about containers and understanding that concept of what they are and how you get to them from maybe where you've been developing software over the last sort of 10, 15, 20 years. So the familiarization of that concept, that paradigm shift is key. But along with that as well, though, you've got performance. So they are faster using containers. You can generally get better performance than using virtual machines due to all the overheads that we sort of went through just. But actually, unfortunately, you're never going to get as fast as you can get running it straight on tin. But it's that middle ground, and certainly something to sort of keep in mind there when you're thinking about our containers, the right sort of approach. Right, just to take you on to the next slide, then I'm going to hand you over to Alex, and we're going to have a look at some of the architecture approaches.
Thanks, Tom. So I thought I'd sort of draw out a couple of key architectures that are mentioned, one of which is very much considered synonymous with this notion of running containers, and that's microservices. And I suppose its opposite, big bad older brother, the monolith. Now, what is a monolith? So it seems to be a bit of a sort of shift in the industry in terms of the use of the term monolith. And unfortunately for the word monolith, it is supplanted the word legacy. And so people, when they refer to legacy systems, also in the same breath often refer to them as the big bad monolith. But is that necessarily fair to a monolith application? So what is a monolith? So typically consists of three key components as per the diagram. You get your client user interface, a server-side application, and typically a database. But only, I don't know, 10 years ago, N-tier was all the rage. That was what you'd refer to as like a decent modern application. But technically, N-tier is a monolith application architecture. So what types of monolith could you get? Well, single process monolith, I suppose that's the traditional view of a monolith. You have your one application deployed and wrapped up in a single process, probably running on one server, possibly a VM, possibly bare metal on an actual tin server. You may even have a sort of modular monolith, and that's where at least you've got some kind of distinct areas of the application that can be worked on individually. They might even have independent data stores, but it's still packaged and deployed as one. You need a lot of engineering discipline with this approach because what people tend to find is that they grow over time and become incredibly complex, and these interdependencies between these sort of, what I suppose start out as nice, simple modules within your monolith design eventually evolve to sort of a convoluted, tangled spaghetti mess. And that's where you get your distributed monolith. And that's where you might well be running multiple processes, but they're so dependent on each other that they all need deploying as one big bang release. And if you've got, say, a release coordinator in your team who's saying, oh, okay, right, we're going to deploy on, I don't know, October the 10th, everyone get ready at 7 a.m. You're deploying that part, you're deploying that part, everyone click go at the same time. If that's happening, you've probably got a distributed monolith application on your hands. So what are the benefits of a monolith? So, I mean, painted in a pretty bad light so far. Well, fundamentally, it's simple. The old acronym YAGNI, you ain't going to need it. So there's a lots of talk of microservices, and, well, you know, it's the sort of standard architecture approach these days. It might even go as far as serverless, heaven forbid. But is it actually necessary for your application? Maybe that's a question you might want to ask yourself when, particularly if you're in a greenfield scenario, look at you. So what are the downsides of monolith? Well, I've already mentioned slow to release, bundling big changes together. They're also brittle. You know, make a change in one place, it might have unintended consequences elsewhere because there's not that sort of nice sort of segregation and sort of interface layers between. So there potentially could have crept in some bad coding practices over time. So what are the, I mean, I've done a lot to sort of question whether or not you need microservices, but what are the benefits as an application of having microservices? Well, independent deployability. If you want to make a change on a particular microservice, i.e. an independent module of your application that you're deploying as an individual part, you can actually deploy that independently. It can be worked on in isolation, so you can have different teams working on different parts. Think of the Netflixes of the world. They're all working on oodles of microservices, all talking to each other. You've got smaller areas of concern. So rather than having to get to grips with a massive application domain, you might actually have teams that only have to focus on a smaller area, and you can make smaller incremental changes. You also have the ability to work with nice sort of CI/CD processes, so you don't have the old release train of old that everyone has to get on and punch deploy at the same time. Things can go as and when they're ready. You can also utilize cloud native services to host your applications. So a lot of the cloud native solutions out there are all tailored towards the latest architecture patterns, such as using microservices or serverless. And nobody ever got fired for hiring IBM. that tired old phrase potentially, but if you're working on microservice architecture, then it's the latest and greatest. So that's great. So what are the downsides of microservices? Well, requires the transition of mentality for developers from what is traditionally a strictly development role to throw it over the fence to the operation team, who will then punch the buttons, copy the files up, and get that application deployed to you. You're moving from that paradigm to this DevOps paradigm, where developers have to, as a result of the architecture pattern, have to actually transition to a basic understanding of how it all ties together. Otherwise, they can't consume the services that they're referring to. It can take time to establish good deployment pipelines and development practices that work alongside those things. Operational complexity will also go up with more moving parts. So you're going to expect that there's a greater onus on your operations teams to be able to monitor multiple parts of the application that potentially might creak depending on different times of the day, and all sorts of metrics to gather around disparate places. If you have an existing monolith application, it can take significant time to break that up into microservices. And where to start is the conversation of many a book and podcast, and frankly out of scope of this talk here. So questions to ask yourself: greenfield application. So if you're categorically certain your application will grow in complexity to the point where you need microservices, then that's great. But counter question: are you categorically certain that simple architecture would not be an easier place to start with? Do you also have the development capacity to handle building, deploying, and running a microservices ecosystem? As I already mentioned, it's quite a lot of effort. And so if you're in brownfield, like most of us are, I suppose, working with a big old legacy system, has the complexity of this application got to the point where it has to be broken to microservices? Or have you got distinct areas or modules in the application that can be broken off the monolith with relatively few interdependencies? Is it going to cause you a big headache as a development team? Or would just a simple targeted refactor of your application actually suit the business better and take less time and involve, frankly, a heck of a lot less risk? Okay, so you've decided the answer to all those questions is yes, you still want microservices. Well, let's roll back to the fundamentals about building and managing containers. What's involved? Handing over to Tom for this bit.
Okay, nice one, thank you. So if we're talking about containers, we're quite likely to hear about two popular tools and platforms used to build and manage them. And these tools are Docker and Kubernetes. So Docker, hoping that most people have heard of it before, it's a popular runtime environment, and it's used to create and build these your software sort of inside containers, using Docker images to deploy containerized applications or software into these multiple environments that we might have. So Docker was built on open standards, and it functions inside most common operating systems such as Linux, Windows, and other on-prem or cloud-based infrastructures. However, though containerized applications, well, any application, but specifically containerized, where everything's broken down into these small packets, can get really complicated. So these applications might require hundreds to thousands of separate containers in a production environment. And this is where the container runtime environments benefit from the use of other tools to orchestrate and manage all of that. So Docker does have its own mode of operation, which allows orchestration of containers called Docker Swarm. However, like we said before, one of the most popular ones, one of the most popular tools, I'm sure we've all heard it before, is Kubernetes, which recognizes multiple container runtime environments, only one of which is Docker. So you're not just limited to only using Docker within Kubernetes. So Kubernetes will manage your underlying infrastructure, your resources for all of these containerized applications, such as the amount of compute, network, storage, and other resources that are required for your applications. And basically, these tools make it easier to automate and scale your application. So there's an element of thinking about how do we want this application to work, what is the footprint going to be like, and the usage, and then do we need the orchestration side of this? And that's some stuff we'll come on to in a bit. The quote that we've got there on screen just outlines realistically how Kubernetes came about, and as you can see, the reason we include it is because Docker was that direct inspiration for bringing Kubernetes in. Okay, so I'm going to move on to this next slide in a second. This is the one where we are talking about, I guess, our strap line and our headline. Why or even is Docker a blocker? So I'll pass you on to Alex now.
So potentially a bit of a cheeky title here, and maybe that's what sees some of you guys to come in. But I'm curious whether or not people were alarmed, I suppose, when they heard, oh, Kubernetes is deprecating Docker. I know that's the end of Docker for me. Well, so that was announced in the subsequent release of 1.20 of Kubernetes released in December of last year. But what's actually happening there? And hopefully this diagram will actually help make sense of it all. So what's actually happening? Well, Docker shim was deprecated in Kubernetes as the part of the release in December of last year, with it being scheduled to be fully removed in version 1.23. Now, what does that actually mean? Well, only container runtimes which support the container runtime interface. And that's what the kubelet, which is, I think of it like the brains of the Kubernetes engine running on each node, how it communicates with the underlying containers. So only container runtimes which support the container runtime interface will be supported in Kubernetes going forward. So don't panic. This does not mean that your Docker images that you've produced will not run on Kubernetes anymore. So all that Kubernetes is doing by deprecating Docker as a whole is removing the unnecessary additional hop to access the underlying container runtime that your Docker images run on, and removing a lot of bloat in the process. So Docker itself is a massive monolith application. And way back in 2016, they actually started Containerd as a project, and they chose to open source it later that year. And what the actual move is to remove this Docker shim component, which Kubernetes themselves made, and replace it with a container runtime interface compliant Containerd implementation of the runtime. Docker already produces images that run on Containerd. So all of your images that you've produced thus far will run so long as you're running on a Docker engine that is greater than 1.11, which was released back in 2016. So as the latest version, as of writing, Docker engine, having just got latest today, is 20.10.8. Unless you're way behind, you'll be building Docker images that run on Containerd. So will you be affected? Well, firstly, as I just said, if you're simply writing code, containerizing it and shipping it, you're not going to be impacted. In fact, you probably won't even see or feel a difference. However, if you're a Kubernetes admin running your cluster on, say, bare metal, you will be impacted, but not in a terrible way. All you need to do is replace the Docker runtime with CRI.o or Containerd or another CRI compliant runtime before you update to version 1.23, when Docker will be fully removed. If you're using a cloud native Kubernetes service such as GKE or EKS or AKS, you may need to make sure that the platform is configured correctly to use the CRI compliant runtime. AKS, Microsoft's Azure Kubernetes service, for instance, is set to move to default to Containerd as of version 1.19. So largely with that update, as long as you do a bit of testing, you may find that your images are running just fine. Nothing to worry about there. So what should you look out for when changing runtimes? If you're doing anything a little bit more complex than running a typical container, perhaps, dare I say, referencing the Docker CLI at runtime from within a container, you may want to look for alternate tools. Anywhere where the Docker CLI is referenced directly at runtime, such as node provisioning scripts that call Docker or use Docker via its control socket, or kube control plugins that require Docker CLI or the socket, or a Kubernetes tool that require direct access to Docker, e.g. Kube image pooler, which may actually be pulling images directly from, say, a Docker registry and then spinning up containers within Kubernetes. So is Docker pointless now? Kubernetes have just announced that it deprecated. Well, absolutely not. Docker Desktop is still providing a highly compelling development environment for local development, for pulling shared images from both public and private image repositories, and you can simulate a Kubernetes environment with containers based on multiple OSs and differing base images on your local machine, if you're developing on Mac, Linux, or Windows. And Docker Hub, which is very much sort of goes side by side with Docker Desktop, is a great place for housing those shared images, and or public and private ones, and other registries exist depending on your cloud provider of choice. So we answer experience of running containerized microservices in Kubernetes in production for a number of our clients, and we thought it'd be helpful to move on to maybe share some of that experience with you. So I'm going to hand over to Chris, who's going to talk over some of those things.
Yeah, thank you, Alex. So hopefully a lot of you will have come across Kubernetes before, or either possibly you're thinking about using it because they are so tightly coupled with the containers. So when we were thinking of what to write for this talk, we thought one of the good takeaway that we could give is some tips, tricks, and gotchas, as Alex said. So here are just a few from our experience. So the first to mention is the control plane, which is the entry point into Kubernetes that manages your Kubernetes cluster. And the three different cloud offerings have a different approach that they take with this. So Google and Amazon charge for it per hour, but Microsoft don't charge. However, the control plane that you get with Azure is fully managed, and there's a good side to that because it means that you don't need to worry about it. The downside is that it's very restricted. So there are certain things that you can't do. So there's lots of default configuration for Kubernetes that you don't have access to if you're running it in the Azure world. So an example of one of those, which could be problematic, is the length of time that object logs are kept for, and the default is 2 hours. So if you notice that something's gone wrong after 1 hour 50 minutes of something happening, you've then only got 10 minutes for those logs to be available before they go. So the only option, because you can't change that default value, is to add some extra logging so that you pull out all of those logs and ship them elsewhere, so that you can get to them after. But that just adds to your overhead of setup. So that's one of the problems that we've found. Another item is the max pods value. So we've talked about containers, and for the purposes of this, we'll say that one container runs in one Kubernetes pod. So it's a one-to-one mapping for each container, and for the nodes that are run within Kubernetes, which is your virtual machines where your code actually runs, there is a limit to the number of containers that you can run on each of your virtual machines. And again, there's a difference in the cloud offerings here. So if you only use one, I think it's good to know the differences that you may find if you have to switch or go elsewhere. So Google is nice and simple. The value is always 110, so that's easy. AWS is slightly more complicated because it depends on the EC2 image size that you choose. So if you choose a really small box, then the most number of pods that you can have is 4. And if you choose a really beefy box, it goes all the way up to 737, and that's fixed by the VM that you pick, and that's simply because each of the different VMs have different networking capabilities. So it's good to know which size you need before you start. And then finally, with Azure, just like the control plane, it's another problematic area. It's the most complicated one of the lot. So the number of containers that you can run on each node ranges between 10 and 250. It's totally agnostic of the VM type that you choose. So you can have a really small VM and choose to run 250 containers on there if you wish. However, the big problem here is that the number that you pick can only be chosen when the nodes are created. So after they're created, at the moment, you can't go in and change them. So I imagine that in the future, you'll be able to, but at the moment, you can't do that. And the default value, if you either don't know that this figure is there that you can choose, or you forget to set it, the default is 30, which is pretty low.
Yeah, and that's certainly something that we actually fell foul of when a Kubernetes cluster was provisioned on behalf of a client. It was a bit of an expensive continuous improvement exercise to contemplate a migration path to a new node pool because at the point of the cluster being created, the default value was not overridden, and you ended up with 30, the only possibility of 30 pods per node, and that includes actually the system pods as well. Obviously, all the ones that Kubernetes requires to run is included in that total. So yeah, we're contemplating scaling up the number of running pods, and that was unfortunately something that needed to be done before that was a possibility.
Right, it can take a long time to get the actual number right, because it's going to be a bit of trial and error. You don't want to use nodes too big, and then you put all your containers on, and actually the amount of resource that you're using is really small, and vice versa. You don't want to say, I can run 250 on here, and actually it's going to max out the resources, because that's
you need to be pretty careful on your scaling groups then in that case, otherwise you're maxing out the resources of the node.
Exactly. So if you're underutilizing, there is an alternative, which is that you can run multiple containers per pod. So it doesn't have to be a one-to-one mapping. So you can put more containers in, but that just adds complexity and has its own problems that are outside the scope of this. So that's just something to be aware of. So the next thing on the list, the middle one, network policies. So this is where we've got this lovely little diagram here that I did not create myself. There's a chap who's done a talk at KubeConf who I imagine put these images together, and he's got a lovely repo that with loads of network policy examples in there. So have a look at that. It's not too difficult to find. So what network policies allow you to do is add some rules about how containers are allowed to interact with each other, because all of your containers are essentially standalone. So they could make calls out to each other, but actually it may be that you don't want to allow that. So within Kubernetes, you can set up various rules so that traffic is allowed one way, not the other way. If you use different namespaces, for example, you can restrict traffic between namespaces. I'm mentioning this because it's not just a case of having containers and running them. There's actually a lot more overhead, as with the other pieces that we've discussed already. So the final two here, start with Cured. Cured offers an automated approach for restarting Linux boxes or Linux nodes. So the nodes where your machines are running in your Kubernetes cluster are essentially virtual machines, and they can get patched. And if they need a restart, then Kubernetes doesn't pick up on that natively and restart it. So Cured is an option that you can have a pod running, and it basically monitors your machine to check, okay, do I need to restart? Is there any security patches that need this? And then it does so in a safe way. So it will drain all of your pods away. It will move them to somewhere else in your cluster, allow your VM to restart, and then once it's back up, it can take all the pods back and even out the distribution of your pods across your cluster. And then finally, the last one to mention, which is arguably the most interesting of the lot. So by default, Kubernetes, if you're going to run something in Kubernetes, generally there's always at least one instance of your pod or your container running. That's a general rule that Kubernetes has. There is an alternative where you can have jobs. So where you can have a Kubernetes job, and you can initiate that job, and then it would spin up certain pods to do certain activities, and then they'd come down. So that is another option. But the options for kicking off those jobs are fairly limited. So Cada is a nice open source tool that kind of solves both of those problems. So first of all, it allows you to scale down to 0, so you can have no pods of a particular type running at any one time, and also gives you significantly more options of how to kick off Kubernetes jobs. And the way it does this is via trigger mechanisms. So Cada has a whole bunch of different ways that you can trigger the generation of these pods and jobs. So I'll give you an example. So let's say you had Kafka running, and there was a topic on Kafka, and for most of the time the topic was pretty quiet. There's not a lot of activity, and you had a container running in a pod, and its job was to pick up items from the Kafka topic and do something with them. There's no point in a pod being there, sat there, not doing anything, as it's just all that's doing is eating up your resources, which isn't great. So what Cada can do is can monitor the Kafka topic, and as soon as it sees something, it can say, right, I need to kick off a job, or I need to spin up a pod, and then depending on the number of items on that topic, it can spin up multiple instances of pods as well. So it can do all of that scaling for you. So that's just something fun that we've come across that solves a couple of issues that we've had with excess pods that are running. So I hope that's interesting. I guess the only other thing to say is that I've bashed the Azure implementation of Kubernetes a couple of times in this slide. So I just wanted to redeem that slightly by saying that on their site, they do have a best practice guide for Kubernetes, which is generally pretty good. It's kind of half written by Microsoft and half written by the community. So it's slightly contradictory in places and should be taken with a little pinch of salt, but generally it's a pretty good thing. So there's some of our experiences. I'm hoping at the end, if anyone else has any fun experiences or something interesting that they'd like to share with the group, then please do so, because I think we'd all be certainly interested. The three of us would be interested in hearing them. So let's get to that soon. So Tom, I'm going to pass to you for a roundup.
Okay. Okay, thank you. Yes, so let's just quickly go over then what we've been on and get to the good stuff, which Chris just mentioned there about sort of sharing any experiences within this sort of field. So, we've gone through and had a look at possible architectures, your monolith versus your microservices, what a container can give you, containers, are they really all that? Will they fit with your architecture that you want to go for? And I think if you're going down that microservices approach, then absolutely. And it might be amiss of me saying you might be a bit of a maniac if you decided to go for containers without any sort of orchestration. So definitely those are the sort of things that we want to sort of pick up on here and hopefully sort of, give out some useful information to you guys. Lastly, the tips and the tricks on the Kubernetes side, thanks Chris for that. It's useful information for people that are in that neck of the woods and are into these tools and use these on a daily basis to sort of keep applications and software running. So yeah, and I'm sure that some of them have been learned through some very long late nights and getting stuck into some crazy code and configurations and manual reading, I'm sure. I guess just one last thing then really sort of end on really is Docker really this sort of blocker? I mean, Alex, you came in early on with your slide sort of against this title with sort of our take on it. Any thoughts to add to that to finish up?
Fundamentally, don't think so. Yeah, Docker's a great ecosystem. Keep rolling with it. Kubernetes will run your images that you produce. Just might want to be a bit careful if you're doing anything crazy.
Always a sound bit of advice. Right. So firstly, thanks everybody for your interest and attention this afternoon. It's been good to sort of see everybody here. We've had sort of over 20 people in, so that's really good. And we'd like to open up the floor to anyone who's got any questions, or if anybody wants to share any sort of experiences or tips and tricks themselves on containerization, microservices, Docker, Kubernetes or anything like that. So feel free to just give us a shout. And if not, it's not a problem. We can shamelessly plug a few more Answer digital talks that we've got coming up over the next week or two.
Let's do that. Well,
shameless plug it is.
Shameless plug. That's absolutely fine.
Okay, so what have we got coming up? Thanks a lot again for coming on to this event that we've hosted at Answer Digital. We've got a few other things that are coming up as part of the Leeds Digital Fest 2021. So on the screen, we've got product ownership, no longer a hobby. That's run by Kate Louise and Marvi. And that's talking about product owner as a full-time role, not just an aspect of another full-time job. So what makes a good product owner? And are you working with someone who's, bless them, happen to be a product owner and something else at the same time? And whether or not that's actually something that you should really entertain. Putting love in the room, what it means and putting it into practice. Kate Louisa and Tabitha this time. Putting love in the room is one of Answer's values. So what does that actually mean in practice? So that's what we're going to be talking about there. Exploring the world of AWS Lambdas, the tester's journey. Rob, Harvey, and Joe are going to talk about that. They're going to be talking about their experience of testing in the cloud, what they've learned, and how to ensure good test practices. We've got introduction to performance testing with K6. Joe Batt is going to run that one. So there's loads of open source frameworks for performance testing. Apache JMeter is probably the one that springs to many people's minds. Joe's going to talk through K6. It's relatively new on the field, and his experiences with that. And we've got revolutionizing healthcare through AI, and I believe Hadley, Stipe, and Paul are on that. So we're working closely with the NHS in London and Greater Manchester at this point in time, and we've developed a bunch of innovative platforms utilizing some great use of AI. So join us to find out how we're actually changing healthcare from within, working with the NHS. So it'd be great to see you guys along for those talks. So feel free to sign up on the LDF website.
Brilliant. Okay, thank you very much, everybody. Thanks for your time. Enjoy the rest of the evening.
Yes, thank you.
Ben.
Thank you. Bye.